Am I audible? Am I audible? Nabil, Saifullah, Yashika. So up to last class, we have finished this thing. Huh? We have finished LCR circuit. So let's recall LCR circuit once again. So what was LCR? It was series combination of inductor, capacitor, and resistor. So we had an inductor, capacitor, and a resistor in series. The current passing through all these three circuit elements was same. It was I0, I0, I0. In resistor, current and voltage were in same phase. In capacitor, voltage lags by current by a phase difference of pi by 2. In inductor, voltage leads current by pi by 2. Then we calculate, we consider two cases. The first case, across inductor voltage was greater than capacitor. Or you can say that V naught L was greater than V naught C, or equivalent T. You can say that XL is greater than XC. That was the first case. In that case, your impedance was V naught L minus V naught C square plus V naught R square. Or you can say that impedance is root over XL minus XC square plus R square. That was the first case. Or you can say that I naught is E naught by Z. That was the expression for the peak value of current. So when XL is greater than XC, then EMF leads, and this was the phase difference XL minus XC by R. And this was the equation of current and the corresponding equation of EMF. Similarly, we did expression when V naught C was greater than V naught L. The only difference was instead of VL minus VC, in all places we were writing V naught C minus V naught L. So we finished this LCR circuit. After LCR circuit, the next circuit is the RL circuit. We can make RL circuit using LCR circuit. The only difference is we will remove all terms which are having C. We'll just remove terms having C here. I believe that you can tell me about this RL circuit. So if this is resistor, there's no difference in RL and LCR circuit. The only difference between RL and LCR is if you remove capacitor in your LCR circuit, then you will get an RL circuit. So let's solve it together. Huh? So this is the current I naught. What about the voltage? See, this derivation is a part of this derivation that we did. Huh? So all terms are same. So these terms V naught R, V naught L, V naught C are same as we have used in the LCR circuit. So the same terms here. So Akshay, what about the voltage across resistor?
Done anything new yet?
No, nothing. We just have started.
I not.
I'm asking V naught voltage across resistor and voltage across current across resistor. Do they have a phase difference or they are in same phase?
Same,
Sorry,
same page.
same phase. So resistor voltage across a resistor and current passing through the resistor are in same phase. So I naught and V naught are in same phase. What about the inductor, Hishma? Voltage across inductor and current through inductor, are they in same phase?
No.
So which one leads, which one lags here?
Voltage leads and current lag.
Very good. Voltage leads current by a phase difference of pi by 2. So this is V naught F, this is pi. Now, if I draw the phasor diagram, so in the phasor diagram, this is I naught. Voltage is in same phase V naught R. V naught L leads current by pi by 2. So we have to add these two things. Huh? We have to add V naught R and V naught L. Okay, just do one thing. Just go on the pages where we started LCR circuit. This derivation, this calculation. Go to this calculation. This one. Yashika, Akshay, Saifullah, did you get this calculation in your notes?
Yes, sir.
Okay, now let's substitute the value. See, the circuit that we are solving here, there is no capacitor. So what will be the difference? Instead of V naught C, you will put 0 and your, see if you do this thing. See, this is the expression of impedance, XL minus XC square plus R square. So in the previous circuit, in this circuit, LCR circuit, you have XL and XC both. But when you do RL circuit, then there is no XC. So what you can do is you can remove this XC from it. Or shall we derive it? Okay, let's derive this expression.
XL square plus
Yes, yes. Let's derive this expression. This derivation may come in your exam. Let's derive this expression. It's a one-line calculation. Okay. So see the net voltage across the circuit, total voltage. Cephala, what will be the expression of the total voltage here? E naught. You are adding these two voltages, V naught L and V naught R. What will be the expression of total voltage?
so VL square plus VR square.
Right. That will be V naught L square plus V naught R square. This is first thing. What is the relation for V naught L? Yashika, what was the formula for V naught L?
Sir, I naught into XL.
So V naught L was I naught XL whole square plus I naught XC whole square, I naught R. So just like the previous calculation, we can take I naught square as common. So this I naught will come outside and you will be left with root over XL square plus R square. Then you will get E naught by I naught. E naught by I naught, which is root over XL square plus R square. And this V naught, E naught by I naught is known as Z impedance. And impedance is root over XL square plus R square. This is impedance, root over XL square plus R square. This is the expression of impedance. So if you want to remember the formula, just remember the formula for the LCR circuit. Just make small changes in formula of LCR circuit. For RL circuit, put C is equal to 0. That's it. Z is this. After Z, you can write the equation of current. I naught is E naught by Z. Then you can calculate the phase difference. So when you calculate the phase difference, look at this triangle, this right angle triangle. This is O, this is P, this is Q. In this right angle triangle, you can calculate the value of tan phi. When you calculate this value, tan phi, it comes out to be, it's perpendicular upon base, so it's V naught L by V naught R. So V naught L divided by V naught R. What is V naught L? It's I naught XL. What is V naught R? This is I naught R. So I naught will cancel this I naught, and you will get that your tan phi is XL divided by R. So this is the phase difference. Now, if you look at this diagram very carefully, you will see that EMF leads current by phi. So if I take equation of current to be I naught sine omega t, then the equation of EMF will be E naught sine omega t plus phi. If you take E is equal to E naught sine omega t, then say current lags by EMF by phi. So the equation of current will be I naught sine omega t minus. And cos phi is R by Z and P average is E RMS I RMS into cos phi. So this is about the RL circuit here. So if you know LCR circuit, then for RL circuit, just put the terms having C to be 0 and you will get your RL circuit. No return. It's just the extension of the derivation that you did for LCR circuit. In the calculation of LCR, we are just substituting XL equal to 0. We're doing nothing else. None of you share your question paper with me. I ask you to share the photographs of your question paper. Please try to share the PDF after the class. Maharaj, is it clear, this whole calculations? Sorry. Scroll up or scroll down?
It's over.
Nabil Khan, you are absent for last few classes. What happened?
Yeah, sir, last one class because I was having exam.
Got it, sir. Yes, everyone had written up to here. Phase difference. Can I scroll it? Saifullah, Noah.
Yes, sir.
Yes, sir.
Noted. Nabil Ahmed. You have written the previous section? Okay, so must have written up here. Huh? So after this RL circuit, the next is the RC circuit. So in RC circuit, we will just remove inductor from the LCR circuit. The rest of the calculations would be same. So you have a resistor and just a capacitor, and this is your current I naught sine omega t. So current in both the circuit elements would be same. What about the voltage in resistor? In resistor, voltage will lead, lag. What will happen with the resistor? Anshika, in resistor, what is the phase difference between current and voltage? No answer from Anshika.
Sir,
Yes.
omega t minus 5.
No. Noha, what's the phase difference between resistor and between current and voltage in a resistor?
So 0.
0. They are in same phase. And what about the capacitor? Anshika, what's the phase difference between current and voltage in a capacitor? It's pi by 2. Voltage lags by current by a phase difference of pi by 2. So when I draw the phasor diagram, see this is current. This is your voltage in the same phase. And this is your voltage across capacitor, which lags this current by a phase difference of pi by 2. And this is the net EMF E. The phase difference between current and EMF here is phi. This is the phase. So what we can do is we can calculate, see, you have a vector V naught R, you have another vector V naught C. So the net EMF is, if I calculate the net EMF, just like the previous circuit, this will be V naught C square plus V naught R square. What is V naught? And this is E naught. So yours E naught is root over, it's I naught XC whole square plus it's I naught R whole square. So what you can do is you can take this I naught as common and you will be left with root over XC square plus R square. And this XC square plus R square is known as Z. Z is XC square plus R square. In the previous section, it was XL square plus R square. This was your Z. So once you have Z, you can calculate the equation for I naught. I naught is E naught divided by the impedance of the circuit. Similarly, you can calculate phase difference, tan phi, which is XC by R. If you see lead and lag, so this is your EMF and this is your current. So Hishma, which one leads here and which one lags? I naught and E naught. Which one leads and which one lags?
Current I not leads.
Current leads and EMF lags. You can, when you start with the equation of current, you will say that EMF lags by current by a phase difference of phi. But when you start with the equation of EMF, you will say that current leads by a phase difference of phi. Current is I naught sine omega t plus phi. So you have cos phi, which is R by S. You can calculate average power E RMS I RMS cos phi. So that is about the LC circuit. So once you have the LCR circuit, you can derive all of the circuits. In LCR circuit, if you remove the term having inductor, then you will get your RC circuit. Just note it down.
The current leads by pi by 2 or just pi?
Phi. The phase difference between current and EMF is phi. Pi by 2 is in just 3 circuits. One is capacitor, another is inductor, and there will be one more circuit, LC circuit. In all these 3 circuits, the phase difference is pi by 2. Otherwise, phase difference is just phi.
Sir, can you explain the RC circuit, sir, once more? I did not get, sir, the perpendicular I naught, V naught.
Miraj, see, I'm not explaining anything new in RC circuit. I'm just taking this LCR circuit this LCR circuit that we derived in the last class. I'm just using these terms here. So in RC circuit, I'm removing this inductor. So the derivation
Yes,
that
sir.
we did in the last class, the voltage and current were in same phase, and the voltage across inductor lags by current by a phase difference of 5 volt. I'm just removing this term, nothing else. Okay.
Okay, sir.
अंशिका, आप क्लास में थोड़ा रेगुलर रहा करो, थोड़ा अटेंटिव रहो, क्लास के एंड तक रुका करो. देखो फिजिक्स बिगड़ रही है तुम्हारी. तुम बहुत अच्छा परफॉर्म कर रही थी, बट कुछ दिनों से मैं देख रहा हूँ परफॉर्मेंस गिरती जा रही है. तो इसमें somehow- संभव मुद्किल, आप is your first class with me or you are with a
Sir,
different
this is
name?
me at Prith. Sir, I like, joined from the other side.
Arpit. Arpit, you are late by 30 minutes. You missed two
Sir,
topics. Yes.
sir, I had my chemistry class, so I was on my way back.
Can I scroll it now? Akshay, Nabil, Saifullah, Ishma.
Yes, sir.
Yes, sir. You can scroll.
Sorry, your voice is not very clear. Nabil, you're saying something?
Not me, sir. I think Saifullah.
It's okay. Saifullah, you're saying something?
No, no, sir.
So that was about the circuit having a resistor and capacitor. Now there's one more type of circuit, which is LC circuit. After LC circuit, we'll start doing numericals. So can I scroll it now? Ishika, Noha, Miraj, written up to here?
Yes, sir.
Yes, sir.
Okay. So the next circuit is LC circuit. So in LC circuit, you have an
The
inductor.
power average, can you just show it, sir? The power average.
Yes.
You done, sir.
So the next is LC circuit. So you have an inductor and a capacitor, and they are connected in series to a current I naught sine omega t. So they are in series. So current would be same in both the capacitors. What about the voltage across inductor? Cephala. The voltage across inductor, it will be in same phase with current, or there will be some lead
No,
or
sir.
lag.
It will lead.
Voltage will lead, right? And what about capacitor cephala?
It will lag.
Voltage will lag by a phase difference of pi by 2. When you draw the phasor diagram, this is I naught, and this is V naught L, and this is V naught C. See, V naught L and V naught C are exactly in opposite directions. If you have two vectors which are acting in opposite direction, then what will you do to get that total voltage? We subtract them, right? So we have two options. Either we can subtract V naught L from V naught C, or you can subtract V naught C minus V naught L. That depends which one is greater. So in the first case, I am taking V naught L is greater than V naught C. So if V naught L is greater than V naught C Hishma, then what will be the net EMF? Hishma, what's the angle between V naught L and V naught C? If you look at this phasor diagram, what's the angle between V naught L and V naught C?
180.
180. So what you will do to calculate the net voltage, you will add, you will subtract. What will you do?
We'll subtract.
You will subtract. They're acting in opposite direction, subtract. If I'm saying that this term is greater than this, so what will be your E naught? V naught L minus V naught C will do, or V naught C minus V naught L?
V naught L minus V naught.
V naught L minus V naught C. So that is E naught, which is V naught L minus V naught C naught. Okay, Arpit, do you remember expression for V naught L we did in the previous lecture also while doing LCR circuit? How much was V naught L in LCR circuit? Okay. Anshika, do you remember any expression for V naught L we did in the last lecture also in the LCR circuit? In fact, we started the derivation with the expression of V naught L in V naught C. Okay, no answer from Anshika. Alia, what relation for V naught L and V naught C? Very good. See, we have used now V naught L is I naught XL, V naught C is I naught XC. So instead of V naught L, you can substitute I naught XL. So what you can do is you can write after this. E naught is I naught XL minus I naught XC. What you can do is you can take I naught as common. So you are left with XL minus XC. This XL minus XC is the impedance. So your impedance is XL minus XC now. This is the impedance of the circuit. If you look at the phase difference between V naught L and I naught, can you compare lead and lag here? Which one leads and which one will lag? This is your net EMF, huh? E naught, and this is I naught. Akshay, can you tell me lead and lag, which term is leading and which one is lagging?
V naught L is.
And E naught, no? E naught
sir.
lags current by a phase difference of pi by 2. So here the phase difference is pi by 2. You can say if I is I naught sine omega t, then EMF will lead. But if you write E is equal to E naught sine omega t, then current will lag. Power factor will be 0, average power will be 0. But what if I take the second case? If I take second case, case 2, that V naught C is greater than V naught L. This is it. This is I naught. This is your V naught L. This is your V naught C. So what will be the expression of E naught now? Nabil Ahmed. What will be the expression of E naught now? Yes, Nandit. I'm saying V naught C is greater than V naught L now. So what will be the E naught now?
Sir, V naught C minus V naught L. V naught
C.
C
Yes.
square plus V naught
No,
L
no,
square.
no need of square. Both are
Okay,
acting
sir.
in opposite direction. If they're acting in opposite direction, then you can directly subtract.
Yes, sir.
And how much is V naught C? It's I naught X. V naught L is I naught XL. So your E naught is, you can take I naught as common. And you can write this as XC minus XL. So you can write this as it's E naught by I naught, which is XC minus XL. And how much is XC E naught by I naught? That is Z. So the impedance is XC minus XL. This is the impedance. If you want to calculate I naught, then I naught is like all other circuits, it's E naught divided by Z. Phase difference here is also pi by 2. Phase difference is pi by 2. And if you consider lead and lag here, see, this is your E naught now. This is E naught. So it's very clear, like EMF now lags behind by current by a phase difference of pi by 2. So you can say that EMF lags current by pi by 2. So if you write your equation of current as I naught sine omega t, then the equation of EMF will be E naught sine omega t minus, or rest of the terms like average power, power factor will be 0, just like the first case. So the only difference in first and second cases is lead and lag. In one case, EMF leads, in the another case, EMF lags. Note it down as a third circuit, LC circuit. Then we start the numericals. Haji, can I scroll it?
Yes, sir.
So till now, how many circuits we have studied which have wordless current? See, this LC circuit also have wordless current. So how many total circuits we have studied having wordless current?
Sir, two, sir. I think.
Two, including this LC. Including LC, it's three. The first was circuit having inductor only, then circuit having capacitor only, then this LC circuit. Three circuits. Haji, can I scroll later? No?
Sir, 1 minute, sir, please.
यशी का एग्जाम हो गया?
सर फिजिक्स का हो गया, बाकी सब्जेक्ट्स का भी चल रहा है।
कैसा हुआ आज?
तो फिजिक्स का अच्छा था।
सिलेबस कितना था आपका? एसी तक था ना?
यस सर, एसी तक का है।
क्वेश्चन पेपर शेयर करना बचे आफ्टर द क्लास.
यस सर।
Okay, so now let's start doing questions. I will do questions on RL, RC, LC, and all. So let's start with the questions of NCERT itself.
Sir, 1 minute, sir. Okay, then. Sir.
So let's start with the questions of NCERT. So let's start with this question, 7.13. Note down the question and then solve it together. Yes, written. Have you written this question? 7.12?
1 minute, sir.
Arpit, are you writing this question?
Yes, sir.
Yes. Can we start now? Okay, let's start this calculation. Anshika, which circuit is this? Huh? We have studied LCR, LC, RL, LC. Which circuit is this? Arpit, which circuit is this? This circuit
Sir,
is
LR.
LR. Very good. So you have inductance and you have resistance. So this is an LR circuit, inductor and resistor in series. So here the inductance is 0.5 Henry and resistance is 100 ohm. It is connected to a 240 volt. So it's 240 volt. Which value of voltage is this? EMF. This is the RMS value or the peak value. Which value is this? Nothing is given. That means it's the RMS value. And the frequency is 50 hertz. This is the given data. You are supposed to calculate the maximum current in the circuit. Before calculating maximum current, see, he's asking about the maximum current. What is the expression of maximum current? It's E naught divided by Z naught. See, E naught is not given, ERMS is given. Saifullah, can you write an expression of E naught in terms of ERMS? Do you remember any relation between ERMS and E naught? Saifullah,
Sir, it will be
sorry.
2I RMS, right?
Yeah,
Or 2
E naught
ERMS.
is root 2 into ERMS divided by Z. How much is Z? Z is root over XL square plus R square. This is the value of Z. Or let's calculate Z separately. Divided by Z. So your Z here is root over XL square plus R square. And what is the expression of XL? What is XL? XL is omega L. So it's omega L square plus R square. So when you substitute these values, you will get Z is root over omega. How much is omega? If nu is 50, then omega is 2 by nu. So it's 2 into 3.14 into 50. It comes out to be 314 radian per second. So it's omega, which is 314, L, which is 0.5 square, plus R. How much is R? It's 100 ohm. It's 100 square. So that is your Z. So if you substitute this value of Z here, you will get iron. And see, what is the next question? Next question asking about the time lag. For calculating time lag, we first need phase difference. Is this first part clear? I'm not calculating the exact value. It will take some time. Can I leave these calculations here? Yes, no. Can I leave this
Sir, how you
calculation here?
got ERMS?
Sorry?
ERMS. How do you get the ERMS, sir?
ERMS is given in the question. It's given that 240 volt. If nothing is given, if nothing is mentioned about the voltage, then take it as RMS value. In the second part is asking about the time lag. But to calculate time lag, you first need the phase difference. What is the formula for calculating phase difference in this circuit, Noah? I need phase difference first. What's the formula for calculating phase difference? Arpit, what is the formula for calculating phase difference in RL circuit? Haji Arpit, formula for calculating the phase difference. Right, Alia? Yashika, formula for calculating the phase difference in RL circuit.
Sir, XL minus XC.
Which circuit is this? Is it an LCR circuit or just an RL circuit?
XL by R.
XL by R. How much is XL? It's omega L divided by R. How much is omega? It's 314. How much is L? It's 0.5 divided by R, which is 100. So when you multiply it, it will be 2 ones are 1, 5, 7 by 100. So you will get that your 10 phi is 1.57. And your phi will be tan inverse 1.57. So if you have phi, how to calculate the time lag? Time lag is just phi divided by omega. This is how we calculate the time lag. It's phi by omega. Phase difference divided by omega is the time lag. Is it clear? Saifullah,
Yes, sir.
Ishma, Akshay,
Yes, sir.
Nabil?
Sir, we
Anila.
can't actually calculate the tan inverse of 1.57, right, sir?
To calculate tan inverse 1.5, you either need a trigonometric table or a scientific calculator. You can leave it here only.
Yes, sir.
In exams, they will not expect from you to calculate tan inverse 1.57. Either they will give it in the question. If it is given in the question, then you can write. Otherwise, you can leave it here. Do it.
Yes, sir.
If you connect the charged capacitor.
No, I need one more lecture for this chapter. It will take one more lecture. Yes, everyone have written up to here? Nabil, Akshay,
So writing
Anshika.
the second part.
Okay. Anshika, written?
Sir, just a second.
Done, sir.
Let's write down this question number 7.15. Yes, have you written this question? 7.15?
Just one, sir.
One answer.
Done, sir.
Okay. See the next thing. The next is 7.15. So which circuit is this, Anshika, in 7.15?
LCR.
Anshika, which circuit is this? RC circuit. Huh? So you have a capacitor and you have a resistor in series. And you connect this to an AC supply. What is the value of capacitor? Given value of capacitor? Anyone? How much is this C?
After 100 into 10 raised to power minus 6.
C is 100 microfarad. And how much is the resistance? 40 ohm.
Yes,
What
sir.
is
40,
the source voltage?
110 volts. With
And
frequency of
frequency?
60 hertz. 60 hertz.
So this is the circuit. So what we can do is we have to do various things. Like first of all, you need current. So which value is this 100 volt? This is E peak or E RMS?
Sir, ERMS.
RMS.
Nothing is mentioned, that means RMS value. So just like the previous question, I naught will be E naught by Z. Next, you can write your E naught in terms of ERMS. So it will be ERMS into root 2 divided by Z. Now you can substitute all values here. How much is ERMS? That is 110 into root 2. Root 2 divided by Z. Now we can calculate Z also. That Z is root over XC square plus R square. Next, what we can do is we can calculate the value of XC. How much is XC? XC is 1 by omega C. How much is omega? Omega is 1 by 2 pi nu into C. When we substitute all these values, C pi is 3.14. Frequency is 60. Capacitance is 100 microfarad. So that's 100 into 10 raised to the power minus 6. This much of ohm is XC. So you can easily get the value of Z. You put the value of XC, you put the value of R, you get Z. That's the first part. In the second part, you need time lag. For time lag, again, first you will calculate the phase difference. The formula for the phase difference will be XC by R. Once you have X phi, you can write time lag is phi by omega. So just like the previous question, the formula based thing. Is it clear, everyone? Arpit? Is it clear, or I should substitute the values? Anshika? Anshika, is it clear?
Yes, sir.
Okay, just note it down. So these two were straightforward thing. We will do some modification. We'll do one more question on LC circuit, then we will do some modification. Yes, written.
Yes, sir.
Let's do one more last question from NCRT on LC circuit. This is LC. Okay, if you this 7.16 would be your homework. For doing 7.16, just refer the discussion that we did in capacitor. In capacitor, if you look at the derivation, and at the end portion of the derivation, I have discussed high frequency and the low frequency one. So 7.16 is from that discussion. If you look at the circuit having capacitor only, then in the end, I have discussed that thing, the low frequency discussion, the high frequency discussion. Just go through that.
Sir, is the answer of second one 1.33 into 10 raised to 3?
Second part.
Yes, sir.
I don't have the answers right now. But
Okay, sir.
yes, it's a straightforward thing. Let's write question number 7.18. For 7.16, the portion of the capacitor, the end portion of the capacitor, where I have discussed the behavior of capacitor at high frequency and low frequency. Do this 7.1. Yes. Have you written this question?
No, sir.
Question number 7.18. Sorry. Okay, everyone have written this question as 7.18. So see, which
Sir,
circuit?
last one, sir.
So which circuit is this, Noah, in 7.18?
So LC circuit.
LC circuit. So in 7.18. So you have an LC circuit, you have one inductor, and it is connected to a capacitor. And this is the power supply. What is the inductance here? Inductance.
Sir, 80
Let's say
millihenry.
80 millihenry.
Please just tell me the values. 80 millihenry. And how much is the capacitance?
60
60
microfarad.
microfarad.
60 microfarad. And how much is the ERMS one?
230 volts.
How much?
230 volts.
230 volt. And how much is the frequency?
50 hertz.
So this is an LC circuit. So for an LC circuit, first of all, let's calculate the impedance. Impedance is XL minus XC or XC minus XL. So to decide whether this is XL minus XC or XC minus XL, first calculate the value of XL. See, XL is omega L. Omega is 2 pi nu into L. So it's 2 pi, which is 3.14. Frequency, which is 50, multiplied by L, which is 80 millihenry, 80 into 10 raised to the power minus 3. So it comes out to be 100 into 314, that is 314 multiplied by 8 into 10 raised to the power minus 2. Let me use my calculator. So 314 into 8, 2512 by 100. So it's 25.12. That's XL. So once you have XL, then we can calculate XC also. XC is 1 by omega C. So it's 1 by 2 pi nu into C. So it's 1 by 2 pi is 3.14. Frequency is 50 and C is this 60 microfarad. 60 into 10 raised power minus 6. So this is 100, 314. So 1 by 314 into 6 into 10 raised power minus 5. So it's 10 raised power 5 now. So we have 1 divided by 314 divided by 6. So it's 0.00053. 0.00053 into 10 raised to the power 5. So it's 53. 53. So XC is greater than XL. So if XC is greater than XL, then impedance. What is the formula for impedance here, Anshika? Anshika, what is the formula for impedance in the LC circuit? Impedance in the LC circuit. Arpit, what is the formula for impedance in the LC circuit? Arpit.
Sir, XC minus XL.
XC minus XL. This is XC minus XL. So how much is XC? That is 53. How much is XL? That's 25.12. So it's around 25, 53 minus 25, it's 25, 26, 27, 28. It's 28.120. That is the impedance, 28.120. So if you have impedance, you can do one more thing. Impedance is 28.12. After impedance, as the first part, you need peak value of current. Okay, let's study the question. What we have to calculate here. Current amplitude. Now let's start the first portion. Current amplitude. So Noha, what will be the formula for calculating current amplitude? Formula for I naught.
So E naught by impedance Z.
But E naught is not given, ERMS is given. So what should be the next step? Yes, Noah. E naught is not given, ERMS is given. So what should be the next step?
So under root 2 into ER.
Root 2 ERMS divided by Z. So it's root 2 ERMS, how much is ERMS? ERMS is 110 volt. 110 divided by Z. How much is Z impedance? Z is 28.12. This much of ampere. In the second part, you need IRMS. So, Saifullah, how to calculate IRMS? Saifullah, how do you calculate IRMS here?
It'll be I0 by root 2, sir.
I0 by root 2. So, I0 is root 2 into 110 divided by 28.12 divided by root 2. So, we can cancel it out and it's 100 by 28.12 ampere. Third part of the question. After IRMS, what was the next part of the question? The next part is average power. What is the average power transferred to the inductor? No, the B part is what's the RMS value of potential drop across each element? Okay, fine. We need voltage VRMS across inductor. Hishma, how to calculate voltage across inductor? Okay, it's 100 and it's 230. Okay, sorry. Yes, it's 230. Yes, it's 230. It's 230. ERMS is not 110. ERMS is 230. It's 2. Sorry. Yes. Hishma, how to calculate VRMS of inductor? Voltage across inductor. The RMS value of voltage across inductor. Hishma. Yashika. How to calculate voltage across RMS value of voltage across inductor?
Sir, IRMS into XL.
IRMS into XL. It's IRMS multiplied by XL. Hishma, is it clear now? The expression for voltage?
Yes, sir.
So IRMS is this 230 by 28.12. And XL is this. How much is XL? XL is this 25.1. 25.12. Fourth part. We can calculate VCRMS. How much is VCRMS? It's the IRMS multiplied by XC. So IRMS is 230 divided by 28.12 multiplied by XC. XC is 53. Fifth part of the question. In the fifth part of the question, so we have both things. Huh? What is the average power transferred to the inductor? So this was A part. This was B part of the question. Now we have C part. Average power. Hishma, will you answer this part? Average power across the inductor. No. Akshay, average power across the inductor.
VRMS, IRMS cos.
And how much that 5 will be? ERMS, IRMS is correct. What about the phase difference?
90 degree, pi by 2.
Pi by 2. Very good. So if you have an inductor, the power across this ERMS, IRMS cos pi by
So
2.
0.
And that is. Similarly, you can calculate power across capacitor. That comes out. Similarly, you can calculate average power across the circuit. That is also. Note it down. Noted down. Can I scroll it? Ishma, Anshika, Akshay, have you written up to here?
Yes, sir.
Okay, so that was about the LC circuit. Now I need at most one more class to finish this chapter. We'll be discussing LC oscillation and
Sir,
resonance.
in the C question,
Yes.
sir, in the C question, the first one is power across inductor. Second is power across capacitor. Third one is what, sir?
Average power across the entire circuit, across the
Yes, sir.
combination of inductor and capacitor. Okay, so we'll stop this thing here. We'll start our revision for J unit. So in our revision, we were doing magnetics. So I take some scans from a new book. This is also a previous year's questions, but it has some comparative new questions from this year also. So let's start with this question. This is Biot-Savart's law and Ampere's circuit law. So let's start with the first question. Just have solutions also. Okay, let's start from the first question. Just note down the question. We'll discuss the solution together. No need to write the options. Just write the question and draw the diagram. Then we'll solve it together. Nabil, Akshay, Anshika, Saifullah, Yashika, written.
Yes, sir.
Okay, let's start the calculation. So you have two infinitely long straight current carrying conductor and they are at the right angles to each other. So if they are connected, that means this is the finite time and this is infinite. So they are semi-infinite one. So you're supposed to calculate magnetic field at this point P now. So you have two conductors, conductor number 1 and conductor number 2 now. So to get the value of magnetic field here due to a semi-infinite conductor, we use this expression B1 is mu naught by 4 pi. It's I by A. What is A? A is the perpendicular distance between the conductor and the point. The perpendicular distance between the conductor and the point is this Y. From here to here, the separation is equal to the Y coordinate. Then sine theta 1, one end is subtending an angle theta 1 here. So sine theta 1 plus sine The point which is going at infinity, what angle with this point will subtend at this P point? The end which is going at infinity, what angle this end will subtend at T? Does anyone remember this angle? Akshay. The end which is going
90
at
degree.
90 degree. The sine theta 1 plus sine 90. So your B1 is mu naught I over 4 pi y. It's sine theta 1 plus sine 90, which is 1. So that's the first equation. After B1, next what you can do is you can calculate the value of B2. Or let's first calculate sine theta 1. See, we can calculate sine theta 1 also. It's a right angle triangle. See, it's a right angle triangle. This is y. This is equal to x. This is the hypotenuse, which is root over x square plus y square. So when you substitute the values, your B1 is mu naught I over 4 pi y. Sine theta 1 is perpendicular upon hypotenuse. So this is perpendicular is x. Hypotenuse is x square plus y square plus 1. When you apply right hand thumb rule for the direction of the magnetic field, see, this is the direction of current. Place your fingers in the direction of current and curl it towards the point. Thumb is going inwards. So inwards means minus of k cap. Similarly, this is for the second wire also. You can calculate the magnetic field due to second wire also, B2. So it's mu naught I by 4 pi. Can you tell me how much is the perpendicular distance, this one from the wire to the point? Answers: Nabil, Akshay, Anshika, Saifullah.
Can you repeat again?
X
How, what is, yes, x. The perpendicular distance between the wire and the point, that's x now. Na? So I by x. One angle is theta 2. So this is sine theta 2. And this end is going at infinity. It will have substance an angle of 90 degree here. So it's sine 90. So B2 is, it's mu naught I by 4 pi x sine theta 2. Now let's calculate sine theta 2 also. Sine theta 2, how much will be sine theta 2 here, Nabil? In this right angle triangle? This is y, this is x. Nabil Ahmed. Sine theta 2 will be perpendicular upon base. Perpendicular is y. Hypotenuse is root over x square plus y square. And sine 90 is 1. So for the net magnetic field, you will add them up. You will add B1 and B2. So how much is B1? B1 is, and also the direction. For direction, just place your finger along the direction of current. Current is upwards, and curl it towards the point. Thumb is going inwards. So this is again minus of k cap. When you add them up, you will get, C, it is mu naught I by 4 pi y. It's x by root over x square plus y square plus 1 plus mu naught I by 4 pi x. It's y by root over x square plus y square plus 1. See, since minus I cap, both have minus I cap, now you can take minus chi by k cap as common. In the next step, we can take some common, like mu naught I by 4 pi. We can take these terms as common, and you would be left with, it's xy root over x square plus y square into y plus 1. Plus it's y by not y will
So
multiply
why
with
will you?
here also. It's y by, it's x into root over x square plus y square. Plus it will be 1 by x here. So what we can do it now, it's mu naught I by 4 pi. We can take something as LCM. A very lengthy calculation then. What's the options? What are the options? X, Y. Okay, the ratio of current in both the conductors is 1:1. Current is in the magnetic field at point P. Current is same. LCM will be xy into root over x square plus y square. So we have here, we have x square here. We have x into root over x square plus y square here. And we have this x will cancel out y square here. And we have y into root over x square plus y square here. So we have mu naught I by 4 pi. So this is x square plus y square. Then you can take root over x square plus y square as common. And we have x plus y divided by xy into root over x square plus y square. Okay, so what we can do is we can take root over x square plus y square as common. It will get cancelled out. So this is mu naught I by 4 pi. If we take root over x square plus y square as common, that means here we are left with just root over x square plus y square. And here it's x plus y1 divided by xy into root over x square plus y square. So see, this will cancel this term. So it's mu naught I by 4 pi. Denominator we have xy, so we have root over x square plus y square plus x. So which option? Option is correct. Okay. So this is again based on Biot-Savart's law for a straight conductor. We did this in class also. Are you following this calculation? Akshay, Saifullah,
Yes, sir.
Shikha,
Yes, sir.
do it. It's a lengthy calculation, but not that tough.
Sir, why in the second case only we have taken minus k cap?
We have taken minus k cap because magnetic field is inverse. Now, if you apply right hand thumb rule, you place your finger in the direction of current and curl it towards the point. Thumb is inverse, so it's inverse also. Direction is inverse.
Yes, sir. Sir, can you scroll down?
Yes. Yes, written. Okay, let's solve next question. The next is coil having n turns. Yeah, this is a small question. Do it. Question number 2. Do it yourself. Came last year, 2021, 31st August. At least write down the question. I'll solve it. Please at least write down the question. Yes, did you write the question?
1 minute, sir.
I'm sharing the link of this notebook with you. Just go to the JEE NEET revision thing and the magnetics one. You will find all these questions. So I have added almost all questions from Biot-Savart's law. I'm sharing that link in the chat room. So through this link, you can access these questions. These questions have solutions also. Okay, let's start solving. So you have a coil. It's in the form of a spiral. See, this is spiral of this way. This is the spiral. So in a spiral, the inner radius, this inner radius is this one is A, and the outer radius of the spiral is B. So spiral is like a circular coil. So the expression that we should use is that of a circular coil, mu naught Ni by 2R. But the issue is this circular coil, the radius of the circular coil is not fixed, it's changing. If the radius were fixed, we will be using this expression. But since it's changing, so we can't use directly mu naught Ni by 2R. So what we will do is we will consider a small element here. This small element will have some radius x. And this small element will have some thickness. The thickness is dx. This will have this thickness dx. So let's say the small elements have some dn number of turns. The radius of the small element is x. So can you tell me the magnetic field at the center? Anyone? Expression of magnetic field at the center of the coil. See, if I take a circular coil only, the radius of the circular coil is x. I'm asking you to calculate magnetic field at the center. Yashika, what will be the expression for magnetic field at the center?
Mu 0 Ni by 2x.
Mu naught dni divided by 2x. Now the issue is with this dn. How to calculate this dn? To calculate this dn, what we can do is see the total number of turns in the spiral will be n. And the spiral starts from this point, it goes up to here. So the total length in which the spiral exists is b minus a. See, it's a closely spaced one. This is a closely spaced one. This is the inner one and this is the outer one. It starts from here and ends it here. So the total thickness in which this spiral exists is the outer radius minus the inner radius. So you can say that in b minus a length, you have n number of turns. In unit length, you will be having n by b minus a number of turns. In dx length, you will be having n by b minus a multiplied by this dx. Is it clear? This is the step which can create problem. We are trying to calculate the number of
Sure,
turns.
that B minus A, how you got?
See, the spiral starts from the see the spiral starts from here. Spiral starts from here, where the inner radius is A. And it goes up to here, where the outer radius is B. Here, the turns are closely spaced. So if I ask you in what thickness the spiral exists in this much of thickness, which is B minus A. Is it clear? This is the entire thickness of the spiral. Nabil.
Yes, sir.
Yes, sir.
And this B minus A have n turns. This have n turns. B minus A have n turns. You need number of turns in this thickness. You consider in between it, you consider a coil here. And you say that the thickness of this coil is dx. You need number of turns in dx thickness. So what we do? In B minus A, number of turns is n. In unit turns, it's n by B minus A. In dx, it will be n by B minus A into dx. Is it clear?
Yes, sir.
So this is dn. This will be yours dn. So instead of dn, I can substitute this thing here. So your magnetic field is, it's mu naught dn, which is n by b minus a into dx divided by 2x into y. For the total magnetic field, what we can do is we can just integrate it mu naught n I dx by b minus a into 2x. And this integral exists from a to b. So the lower limit is a, outer limit is b. So you can say that mu is constant, n is constant, I is constant. In fact, b minus a is constant, 2 is constant. It's just 1 by x. When you integrate 1 by x, you get log x from a to b. So when you substitute the values, it comes out to be it's mu naught n I by 2 b minus a log x log b minus log a. You can write this log b minus log a as log b by log a also. So if you check the options, 2b minus a log of b by. No return. This spiral is an important question.